Welcome back, Discovery viewers. In this video, I'm going to answer a question why we use metadata fields for deduplicating emails and binary content of a file to deduplicate eDocs. During normal e-discovery processing, we perform a process called deduplication. And during deduplication, we generate hash values. Hash values is how computers are able to compare different pieces of content and see if they are duplicative or not. Now, we use different process to generate these hash values. For emails, we take different metadata fields, we lump them together and use that as an input stream for our hashing algorithm. And for eDocs, we take binary content of the actual file and we use that as a source for hashing algorithm to get an MD5 hash or any other hash value. And then computer compares those hash values together to figure out if we have duplicates or we do not. Well, the question on your mind may be, why do we use these two different strategies for generating hash values? Emails can be stored in the file format themselves, so why wouldn't you just take the file hash, a binary content of an MSG file, and compare it to another MSG file? Well, the answer to that is MSG files contain extra information about email, such as when that MSG file was saved out, making same MSG file saved out multiple times not unique. Now, I know it sounds weird and I had trouble believing it myself until I did a test. And I know you guys would not believe me as well. So we're going to do a test with our favorite Enron PST files. I'm going to open the PST file, take some MSG files, drag them out, and show you what's happening. Let's take a look at my screen. Here's my Outlook, and I'll pick an email with attachment. What I'm going to do is open a folder here, which is a desktop, and I'm going to drag and drop my email so it gets saved as an MSG file. Now I'm going to rename it, and I'm going to call it one.msg. Now, next thing I'm going to do is I'm going to take the same email and I'm going to drag and drop it one more time. And now I'm going to rename it to two.msg. And just so we have a fair comparison, I'm going to take an attachment and I'm going to drag that out. And I'm going to call it one.doc. And I'm going to take the same attachment, drag it out again, and I'm going to call it two.doc. So now let's compare hash values of these MSG files and docs and see what we get. I'm going to jump into something called PowerShell, and I'm going to use a command called getFileHash. I'm going to press enter, and I'm going to enter my first file name, one.msg. Then I'm going to enter two.msg, and then our attachments, one.doc, two.doc. Now, before we run this, let's make a prediction. We made two MSG files from the same source and two attachments from the same source. So what we would expect to see is one MSG and two MSG receive the same hash value, and one.doc and two.doc receive the same hash value as well. So let's run this command and see what we actually get. I am going to press enter to run the command, and what we see here is our one.doc and two.doc did receive same hash value, so they will be deduplicated if they were standalone eDocs. But one MSG and two MSG received completely different hash values, even though we extracted them from the same email in the PST file. So I hope this demonstration answers the question why we are not using binary file comparison as a criteria for hashing algorithm. Those emails simply would not be deduplicated out, and we have to use metadata fields to identify our hashes. That's it for this video. Don't forget to follow vDiscovery on social media networks listed on your screen. And for previous videos, check us out on YouTube. Thanks for watching.